Hello, good day, everybody. Welcome to another edition of Chemistry and Life again today. And I remain your host, Ruki Mercy. Today, I want to continue from my last topic, which is a functional group. Last time, I talked about functional group, and I discussed 3 different functional groups. I discussed the alkanes, and the alkynes. Today, I want to talk about the alcohols. The alcohols, also called the alkanols, and the alkanas, and the alkanones. So, beginning from the alcohols are a class of organic compounds that are characteristics of OH. So all alcohols have this OH group, they call it hydroxy group. This OH group is called the hydroxy group attached to the compound. And this is a general formula: CN H2N plus 1 OH. This is a general formula. So if you see now, you see that here you have 1 carbon atom, that is C, and then when C is 1, so H will be times 2 of C plus 1, which is 1 times 2 is 2 plus 1, 3. That's why you have H3OH. So this is the general formula. This is called methanol, and this is called ethanol. So it has 2 carbons. It's called ethanol, the second member of the series. Then you also have the aromatics alcohol, also known as phenols. That is, of course, phenolic derivative. For example, here is this phenol, benzene, recurring, and OH group. So, and the alcohols are used for so many things. Most of our foods contains alcohols, and some of our creams and most things we use, they are made up of alcohols generally. So they go a long way. They are used in the industry. Now the next member I'm talking about is the alkanas. The alkanas are also known as the aldehydes, and the general molecular formula is CnH2n plus 1 CHO. So they have a good number of examples, and their characteristics because they have this carbonyl group oxygen. They have the carbonyl group oxygen. This carbonyl, when you have a carbon carrying double bond to an oxygen, is called carbonyl oxygen. So the aldehydes, they are called carbonyl compounds because they have this word. All their molecules contain carbon carrying what? Oxygen. An example here I've written here is propanol. It's called propanol because it has 3-membered ring. So from the name propane, you remove the E at the end, you have what? Propanol. So, and they are used in making perfumes in the industries. They have a variety of uses. The third member I'll be discussing today is the alkanones. The alkanones are also known as ketones, and the general formula is CnH2n plus 1 CO. Yeah, CO. Then you have the other part because it's mainly in 2 parts because the carbonyl oxygen is always at the middle. That is not, it's not at the end. Unlike aldehydes, the carbonyl oxygen is on the first carbon, carrying an hydrogen. Like you have here, this is the structure of this propanol. You can see this carbonyl carbon carrying a nitrogen group. But in the case of the ketones, the carbonyl carbon is not on the first carbon. It can be on the second, so depend on the compound. So example of this compound I've written here is 3-ozopentane. This 3-ozopentane, or you call it 3-pentanone. 3-pentanone because it's an alkanone or a ketone, so it's called 3-pentanone. It is 3 because the carbonyl oxygen is on the 3rd carbon. In chemistry nomenclature, we number carbon and all that. We number the carbon chain in molecules. So I'll be stopping here for today. And the alkanols, like for example, acetone is used for cleaning. Most of these are nail polishes. For you see some ladies when they make their nails, they clean them. They clean nail polish. That chemical used in cleaning nail polish is acetone. Very useful in industry. So I'll be stopping here for today. See my next video. Please don't forget to like, share, and comment. Thank you very much. See you.